to understand this notion of agency that every living thing has, and in fact is probably, I think, the defining characteristic, the most defining characteristic of everything alive. Once we understand that that is not coming from the genes, that is a property of the whole organism, perhaps, there might be some ways in which we have to rethink how that process of natural selection is being sort of reflected back into the genome. But I think that there's one area in particular where I think there's going to be, and already is, an interesting discussion that's going on around what this means for evolution, which is what's crucial to a lot of this new biology is not what genes we have and how genes are mutated, but how genes are regulated, how they are actually used. And what we actually find is that if we go way back to organisms that are single-celled, but that seem to be the ones today that are most like the kind of organisms that were probably the single-celled organisms that became multicellular way back in time, whenever that was, we find that actually they have most of the genetic resources that we have. They're kind of ready to go. What they don't have is the control mechanisms, the regulatory mechanisms. And in fact, we can see, and people have done this, that at various stages in evolutionary history, when something profound has changed in the kind of structures that we see, for example, the sudden appearance of complex, multicellular creatures, what seems to change, what seems to matter is not that they got a whole load of new genes. What they got was new regulatory processes, parts of DNA that aren't turned into proteins, but that are involved in switching genes on and off or turning their expression up and down. And so the story of how the genome evolved was regulatory. And there are some people who think that the way that happened was perhaps not actually through natural selection, but just through random drift, which is something that happens in genomes, that you get little changes that, because they don't really make much difference to the organism as a whole, because they're not deleterious, they just kind of get stuck there, but they change the expression of the organism. So there is certainly a very serious school of thought that and very good arguments that at the molecular level, it may be that a lot of the evolution that happened in the more recent past in our own evolution as complex organisms wasn't so much due to natural selection as it was due to random drift. And I want to just emphasize that none of that is at all incompatible with standard neo-Darwinian theory. It just means we need to recognize that it's grown quite a bit over the past 150 years.